All right, let's get right into it. We're going to tackle one of the most fundamental ideas in all of statistics and data analysis, the levels of measurement. Honestly, it's the very first step to making any sense of the data you'll ever look at.
So take a look at these. Zip codes, race results, temperature. They all look like numbers, don't they? But here's the kicker. You absolutely cannot treat them all the same way. If you do, you can end up with some seriously misleading and frankly just plain weird conclusions.
And that brings us to a really crucial point. Before you ever think about running a test or making a chart, your first job is to understand what kind of data you're actually holding. And we do that by classifying it into these levels of measurement.
So as you can see here, all our data gets sorted into two big buckets to start with. Qualitative, which is all about qualities or characteristics, and quantitative, which is about, quantities and numbers. And from there, they break down into the four specific levels we're going to climb today: nominal, ordinal, interval, and ratio.
Okay, let's start at the very bottom, on the ground floor of our data ladder, with the simplest, most basic level there is. Nominal data is really all about one thing: naming things. It's just about sorting data into different groups or categories. The key here is that these groups have no natural order or ranking to them. You see this all the time. Imagine a survey asking how you commute. Your answers, bus, car, bicycle, are just different categories. Car isn't mathematically better or bigger than bus, and bicycle isn't less than walk. They're simply different labels. So you might be wondering, what can you even do with this kind of data? Well, you can count things up. You can find out which category is the most popular, that's called the mode. But trying to calculate the average car brand, it's totally meaningless.
All right, time to climb up a step. Now we're going to add a really important new feature to our data.
With ordinal data, we still have categories, just like with nominal, but, and this is the big difference, we can now put those categories in a meaningful order. There's a rank to them.
A perfect example is one of those satisfaction surveys. We know for sure that very satisfied is better than satisfied. We know a master's degree is a higher level of education than a bachelor's, which is higher than a high school diploma. There's a clear order. But here's the catch with ordinal data. We know the order, but we don't know the distance between the ranks. Is the jump in satisfaction from neutral to satisfied the exact same as the jump from satisfied to very satisfied? Probably not. The scale just doesn't tell us.
So, let's just recap where we are on the ladder. We started with nominal, which is just categories. Then we climbed to ordinal, which has everything nominal has, categories, plus a meaningful order. See how each step builds on the last?
Okay, now we're taking a huge leap up from qualitative to quantitative data. These are often called metric variables, and this is where we can finally start doing some real math.
What makes this level so powerful is that the gaps between the numbers are consistent and meaningful. The difference between 10 and 20 degrees is exactly the same as the difference between 40 and 50 degrees. And because those intervals are equal, we can finally do things like add and subtract.
So what's the one thing that separates the top two rungs of our ladder? It all comes down to the idea of a true zero. A true zero means the complete absence of the thing you're measuring. An interval scale doesn't have that. Think about it. 0 degrees Celsius doesn't mean there's no heat, right? That's just a point on the scale. But a ratio scale does have a true zero. Zero height means, well, no height at all.
And there you have it, the whole ladder, from top to bottom. You can see this beautiful hierarchy building up, right? We go from simple labels to adding order, then to adding equal intervals, and finally to the top, where we have a true absolute zero.
So, we've climbed this whole ladder. But why? Why should you care about any of this? Why does it actually matter when you're working with data?
It matters because everything you do next depends on it. The level of your data literally dictates what kind of analyses you can run, what kind of summaries you can make, and what kind of conclusions you can logically and correctly draw.
Just look at this table. It shows you that as you climb the data ladder, you unlock more and more powerful statistical tools. You can calculate a real average, a mean for interval and ratio data, but if you tried to do that with ordinal data, the number you'd get would be completely meaningless.
And this is where the rubber really meets the road. This isn't just theory, it's your practical guide. Knowing your data's level of measurement points you directly to the right statistical test to use, which means your results will actually be valid. So, the bottom line is this. Understanding your data's level is what stops you from making huge mistakes. It makes you respect what your data can and, just as importantly, what it cannot do. It prevents you from making claims that the numbers just don't back up.
So I'll leave you with this thought. The next time you see a statistic or a fancy chart, I hope you'll pause for a second and ask yourself what's really behind those numbers. Knowing the level of measurement is the secret key to understanding what the data is truly telling you and what it isn't.